Hey guys, welcome back to one more video on the channel. And in this video, we are going to solve a question that appeared on JEE Advanced question paper of FIITJEE All India Test Series. So in this video, we are going to solve this particular question. So it is basically a triple summation, and all you have to do is to calculate the value of this particular summation. Alright. So in this video, we are going to understand a lot of important concepts, different types of functions and different properties of multiple summations and how to deal with these kind of questions. So this video is going to add a lot of value to your preparation. So make sure you watch it till the end. And yeah, let's jump in. So before, actually going ahead and solving the question, let us understand few concepts. So now let us see what a symmetric function is. Okay. So if a function is said to be symmetric, if its value does not change under any permutation of variables. So in this case, we have m, n and k. So there are 6 permutations possible for m, n and k, 3 factorial. All right. So if you consider this particular function, if you consider m and k, so when you replace the variables m and k with any of these permutations, the value of the entire function will not change. It is essentially the product of the 3 variables. So similarly, if I have to give you another example, if you consider this particular function m plus n, n plus k, and k plus m. So there are 6 different permutations. So when you put this, you will get this, and when you take this permutation and substitute swap the variables, you will get this particular product. And similarly for these variables, you will get this product. And so you'll get 6 different products for 6 different permutations of m, n and k. Alright. But if you observe, all these products are the same value. Alright. Everything is simply m plus n, n plus k, k plus m. So the positions are just changed, but the entire product is same. So this is an example of a symmetric function. So we are understanding symmetric function because it is needed to solve this particular question. So now let us go ahead and consider the summation given in the question. So if you observe the denominator, so you have this particular function which is symmetric. So this particular function is symmetric. All right. So in the question, it is given as 5 to the power minus of m plus n plus k. So I just got it to the denominator and wrote it as 5 power m plus n plus k. And if you closely observe, this is also a symmetric function. So no matter which permutation you choose, the sum m plus n plus k will always be constant. It will not change for any permutation of m plus n, for any permutation of m, n and k. Alright. Again, in the numerator, this particular product is symmetric, and also this particular product is symmetric. The only non-symmetric term in this question is this particular term. So this is the only non-symmetric term. So now what we are going to do is, so the key idea to solve this question is to make the function symmetric. Make the expression symmetric. Expression as in the whole expression, you have to make it symmetric. So then it will be easy to solve. Make the whole expression symmetric. Make the whole expression symmetric. And how do we do that? So this is the next question that we have to ask ourselves. All right. Now, before doing that, let me explain you one more concept. So let us consider this double summation. This is just for the sake of understanding. So you have 2 double summations. I runs from 1 to 3, j runs from 1 to 3. And even here you have 2 double summations. I runs from 1 to 3, j runs from 1 to 3. Here you are calculating I square j. So when you do that, since j runs from 1 to 3, so you'll substitute the value 1 for j first, and then 2, and then 3. And then you add them up, you have 6i square. So 6 will come out of the summation, and sigma of I square is n into n plus 1 into 2n plus 1 by 6. So you'll put the formula and you'll get the answer. So what happens if I replace I with j? and j with I. Let us see what happens. So here I have done that. I replaced I with j and j with I. Now j runs from 1 to 3. So put 1 first, then you'll get 1 squared times of I, 2 squared times of I, and with 3 you'll get 3 squared times of I. And when you add them up, you will get 14i. So 14 comes out of the summation, and sigma I is n into n plus 1 by 2. You put that. And the answer is still 84. So when you have multiple summations, you can change the variables like this. So this is the thing that I wanted to explain. Now, what does it have? Now, what does it has to do with the current question at hand? All right. So the thing is, to make this particular thing symmetric, all right. So this is m squared term. So we have triple summation of m square n will be equals to triple summation of n square k because of this particular concept. You can just swap the variables. All right. So it doesn't matter what variable you are choosing, you will always get the same answer in the end when you apply these multiple summations. So then again, one more summation possible is k square n or m square k or n square m or k square m. So these are the summations possible, and because of the concept that we have understood here, so all these summations are equal to one another. So all these 6 summations have equal values. All right. So now let us go back to our question. So let us denote the summation we have as S, and you have m n k 3m square n plus m n k upon m plus n plus k, 5 to the power m plus n plus k multiplied by m plus n, n plus k and k plus m. This is the summation we have. All right. Now we will take care of the limits later. For now I am not putting the limits. All right. Here we have the limits as well. So this is the summation we have. Now because of this particular concept, since this is equal to this, this is equal to this, this is equal to this, I can write S as all these summations, and m and k term will be there. Here 3m square n can be replaced as 3m square k, and you have this summation and the denominator. And also similarly I can write the summation as this thing. Instead of m square n, m square k, m square n is over, m square k is over, I can write this n square k plus mnk by the total denominator. Similarly s can be written as this thing. So here you can write k square n, 3k square n, and similarly s can be written as 3 n square m k square m, 3 n square m, and similarly s can be written as 3 k square m. So you have m and k here, m and k, m and k, and all of them has the denominator and same numerator. So s can be expressed in 6 different ways. Now let us say this is your first equation, this is your second equation, this is your third equation, this is fourth, this is fifth, and this is sixth. Now add all the equations. Then on the left hand side you will get 6s, on the right hand side you will get triple summation. So this particular term is m n k in all the summations, so that will be common in the numerator, m n k, and we have to add these brackets. All right. So this m n k, this m n k, this everything will get added up, and you'll get 6 m n k plus you will get the sum of all these terms, 3m square k, n square k plus all of that. So you'll have 3m square n plus 3m square k plus 3n square m plus 3n square k plus 3k square m plus 3k square n. So you will have these terms in the numerator, and in the denominator you will have 5 power m plus n plus k multiplied by m plus n, n plus k, and k plus m. So this is what you have. This is the value of 6s, and we have to find out the value of s. All right. So now what happens is, so let us take the numerator. So let us take the numerator. So this is a symmetric term, this is a symmetric term, this is a symmetric term. So now let us consider this particular term in the numerator. So that is simply 6mnk plus 3m square n plus 3m square k plus 3n square m plus 3n square k plus 3k square m plus 3k square n. This is so now you have this particular expression. Now what is this expression? So let us see what this is. So if you consider the product m plus n, n plus k and k plus m, what will this product give you? So you have to get this idea. So you cannot come and ask me why are you writing and expanding this particular product. You have to get this, because if you have done your algebra thoroughly, you will be knowing that these terms will be generated from this particular expansion. So when you multiply this, you get m plus n and kn plus nm plus k square plus km, and further expand this, you'll get mnk plus nm square plus k square m plus km square plus kn square plus n square m plus k square n plus mnk. So you have these particular terms generated in the expansion of this particular product. So this is simply this product minus 2mnk. All right. So 6mnk, in your numerator has 6mnk plus 3 times this particular product, which is your m plus n, n plus k, k plus m minus 2mnk. All right. So if you multiply this, this is minus 6mnk. So this term and this term will get cancelled. So your numerator is only 3 times m plus n, n plus k and k plus m. So this is your numerator. All right. Now let us go back to the question. So you have 6s is equals to summations. You have 3 summations, and this is m and k outside. So m n k, and this particular expression is nothing but this expression. So 3 times of m plus n, n plus k and k plus m divided by your denominator is 5 to the power m plus n plus k multiplied by m plus n, n plus k and k plus m. All right. So this is what we have. So now what happened? So you got all the terms in your expansion are symmetric. So this is a symmetric term, this is a symmetric term, this is a symmetric term, and this is a symmetric term. All right. So the idea is to add all these different values of s to achieve a symmetric function, and on top of it you can see these two are getting cancelled. So that simplifies our problem very much. So you have in the numerator 3m and k, by in the denominator you have 5 to the power m plus n plus k. So now if you observe this function, this is a symmetric function and this is another symmetric function. All right. So this is the idea. So the total function is symmetric. So the idea is to, convert a non-symmetric function given in the question into a symmetric function. Why did we do that? You will see it in a while. So it will be easy to solve the symmetric functions. So this can be written as sigma I is equals to 1 to infinite, m is equal to 1 to infinite, sigma n is equals to 1 to infinite, sigma k is equals to 1 to infinite, and that can be written as 3 times. So this 5 power m plus n plus k can be written as 5 power n m multiplied by 5 power n multiplied by 5 to the power k. So I'll write these terms as m upon 5 power m multiplied by n upon 5 power n multiplied by k upon 5 to the power k. So this is what we have. All right. Now we have to solve this particular summation. So obviously 3 comes out. So 3 comes out. Alright. Now let us deal with this particular thing first, this thing. So if you observe, let us say the sigma is like integral x y dx. If you have something of this sort, you can bring out y because the integration is with respect to x. So you can write this as y times integral x dx. Correct? So in the same way, here the summation is with respect to k. So therefore, you can bring out these two terms and write it as 3 times sigma m is equals to 1 to infinite, n is equals to 1 to infinite, and these two terms will come out of the sigma 5 power m n upon 5 power n, and this will be simply k is equals to 1 to infinite k upon 5 to the power k. So now we have to solve this. Okay, let us solve that later. Now, but before doing that, so again, now let us worry about this particular thing. So since the sigma is with respect to n, you can bring m times 5 power m outside of the summation. So it will come out and it will sit here, m divided by 5 to the power m. So therefore this is another summation and this is another summation. So you have to solve all these three summations. If you observe, this summation will be is equal to this summation, and all these three summations are equal. That's the point I'm making, because you just have the value k here and the limits are same, 1 to infinite. So alright, so this is essentially equal to sigma m is equals to 1 to infinite m upon 5 to the power m whole cube. Alright, because this are equal. Now let us try to find out what this is. When you put m is equal to 1, you'll get 1 upon 5, and then you'll get 2 upon 5 square, and then you'll get 3 upon 5 cube, plus and so on. Let us say this is p, this summation is p. Now let us see what p upon 5 is. P upon 5 will be 1 upon 5 square. This is AGP, arithmetic geometric progression. So the denominator terms are in geometric progression and the numerator terms are in arithmetic progression. So this is how you solve an AGP. So you have 2 upon 5 cube plus and so on. Now subtract these two. So you'll get 1 upon 5 plus 1 upon 5 square plus 1 upon 5 cube plus and so on is equals to p minus p upon 5. So that is simply 4 by 5 p. So this is simply infinite GP. So a upon 1 minus r. This is the value of that particular progression. Summation, the value of that particular infinite geometric progression. So this is simply 1 upon 4 is equals to 4 by 5 p. So therefore your p will be 5 upon 16. So your p is 5 upon 16. So this particular value is 5 upon 16. So 3 times of 5 upon 16 whole cube. So this is the value we have. And what is this? This is 6s. So this is equals to 6s. But we have to find out s. S is 1 upon 2 multiplied by 5 cube by 16 cube. So 5 cube is 125. And what is 16 cube multiplied by 2? That is simply 8192. So this is the value of this particular summation which is asked in the question. I hope you have got to learn a lot of things from this video, starting from the definition of symmetric function and different examples of symmetric functions, and how to make a non-symmetric function a symmetric function through a series of steps, and then finally how to solve multiple summations. Alright, so if you have liked this video, make sure you give it a thumbs up, share it with your friends, and subscribe the channel for more such content. And also there are a lot of fantastic videos on my YouTube channel. Make sure you check them out. If you have any queries, comment section is the way to reach out to me. and I'll meet you in the next video. Till then, take care.